Hello, grade 8. Welcome to our lesson again. This is now for you, Science Matayom 2. All right, chapter 9 about water, but this is topic 9.2 hazards due to surface water and groundwater. Okay, now look, what are the hazards due to surface water and groundwater? Do you know them? Both surface water and groundwater pose some hazards such as surface water, flooding, soil erosion, landslides, sinkholes, and land subsidence. These hazards can bring serious damage to life and properties. Okay? So look, now what about surface water flooding? You see this picture on the right? Surface water flooding occurs when the runoff cannot soak into the ground or drain into urban drainage systems. It can appear as large puddles, flowing water, or stagnant water on paved surfaces. Do you know what happened to Bangkok about several years ago? That is what happens. So why is this? This is mainly due to a heavy rainfall or a prolonged wet weather and the saturation of soil with water. Okay? Then usually surface water flooding is worse in urban areas as most of the ground such as roads and car parks is paved. These paved surfaces allow little or no infiltration of water. Now, the amount and intensity of the rainfall is not the only factor that increases the likelihood of a flood. Vegetation cover, steepness of the area, soil type, and effectiveness of the drainage system are also influencing factors. I want you to look at this picture. Urban areas are likely to experience flooding during a heavy downpour. Now, floods can have great negative impacts on the economy, environment, and people. During floods, many houses, factories, farms, communication cables, bridges, and vehicles are destroyed. People become homeless and normal life is disrupted. It takes some time for the community to build their lives and businesses. Some plants and animals may die too, so be careful. However, the sediments and organic minerals carried by the water and deposited on new areas can bring fertility benefits. Future crops benefit from it. Floods also replenish surface water and groundwater supplies, resulting in better crop yields in the near future. I want you to watch this video. Wait, I want to make sure that this video is really giving you what you need.
In progress.
Can you hear the sound
Hello,
now?
my name is Ellen, and I am the Outreach Coordinator here at the Flood Control District of Maricopa County. And I am going to show you why flooding is a problem in Maricopa County and what we here at Flood Control do to help keep our citizens and our properties safe from those floods. So we have our flood model here, and our first scenario is going to show what happens when it rains in the natural environment. So before all of these houses were built in Phoenix, we had lots of desert land, and we still have quite a bit, but we have covered that up with our homes and our streets and our stores. But this is going to go way back in time before all of that was here. And when it would rain in the desert, over those natural surfaces, that dirt, the rainwater would get soaked up into the ground, and then when the ground got too wet or too saturated, that water would start to flow out and it would go into our streams and rivers. We call those our floodways. But it's coming out slowly, and it's staying where it needs to stay in those rivers and streams and away from our homes. So we had residents that were building their homes near the water because they needed it for their crops, their vegetation, their animals, and just for their everyday living. But everybody was kept safe. However, people started to move to the Phoenix area, and we started to urbanize, which means we were building our homes and our stores, and all of those things are built with hard surfaces, and we call those impervious surfaces, which means water cannot get through that surface, so it's nice and hard. Well, when we've taken out our natural environment, our dirt, and we replace it with those hard surfaces, there's now nothing to help absorb that water. So now when it rains on our streets, our sidewalks, our buildings, our homes, our schools, it's just going to quickly run off of that surface, and it's not able to stay contained in our rivers and streams, and it starts to flow up into our land, to our homes that are getting flooded, and this car that tried to drive through it got washed away because that water comes very quickly and it's very forceful and can wash away your car. So we want to make sure that we're not crossing those flooded roads when it rains hard like that. So here at Flood Control, we have lots of different professionals that work for us. We have engineers who design and build things. We have planners who work with the community to figure out where the flooding is happening and work with the engineers to help plan different structures to keep that from happening. So we have dams all around the valley, and we also have retention basins in many neighborhoods. And usually there'll be a park that's put in there, because if the park floods, that's okay, better than your home flooding. What those retention basins do is when it rains and the water flows off of your streets and sidewalks and homes and schools, it's going to run into that basin, and it's going to collect it there and hold it back. And then if that basin becomes too full, it will slowly release it back into the natural floodway, those rivers and streams. But as you can see, it's coming out slowly now, back to how it was with the natural environment, keeping it away from our homes and keeping our citizens safe. So thank you all for watching, and have a great day.
All right. Now, do you know how do floods happen already? Wow, that is a wonderful video, right? Okay. So, how to prepare for a flood? Well, this is a flood disaster control video. I want you to watch this one again.
How good a knight are you, Sir Duncan the Tall?
Who will stand and fight
Sorry
with
for
me?
that.
In this video, you will learn how to prepare and react when faced with a flood. If you receive an alert from the authorities that a flood is incoming, keep all your valuables, important documents, as well as hazardous or toxic substances on an elevated surface as high as possible. Prepare your disaster kit and your first aid kit. Follow authorities' instructions on TV or the radio. When the flood is imminent, close all doors and windows, seal off all low-down gaps or openings in your home as best as you can using cloth or adhesive tape for the window frames. Turn off the gas and electricity supply at the mains. Move to an upper floor if there is one. During the flooding, listen to the radio to keep abreast of the latest developments concerning the current situation and to follow additional advice. Do not go out unless instructed to do so by authorities. If for some reason you have to leave your home, Inform your friends and family of your departure and where it is you're going to. Never attempt to cross a flooded area, whether you are on foot or in a car. Stay away from any electrical power lines which have fallen to the ground. Do not wait until the last moment to evacuate if ordered to do so. If you need to drink, make sure the water in question is potable. If the flooding is sudden and you are not alerted, watch out for any messages from authorities, either via radio, mobile phones, or warning sirens. Get to an elevated point away from the water. Signal your location if you are isolated. Do not go and collect your children from school. They are taken care of by teachers who are trained for such events. If you are outdoors, keep away from rivers, rapids, or any other body of water. Get to safety at an elevated point. Remember, cars are not adequate shelters. Here are a few prevention tips. Get informed of the risks in your area and of the related safety measures. Check whether your house is in a flood-prone area. If you live in an area prone to flooding, keep your important documents, valuables, and hazardous products as high as possible. Keep a copy of important documents with your friends or family, or make use of a digital filing service. Keep all electric plugs elevated. If you have children, find out about the measures in place to take care of your children in case of a flood during school hours. If you're differently abled, inform the emergency services.
All right. You know already, right? How to prepare for the flood. Okay? Now that you know it, what about soil erosion? What causes it? Now, moving water, such as rainwater and streams, is the major agent of soil erosion. When a drop of rainfall hits on the bare soil, it can break up the soil and displace the soil particles. As the runoff flows on the bare soil, it removes the topsoil that usually contains most of the nutrients and organic matter in the soil. Soil loss is so gradual that it usually goes unnoticed. When more water runs into tiny, fast flowing channels, it erodes more and deepens the channels. So we can reduce soil erosion by increasing vegetation. That is why we need to plant, right? So the roots stabilize and hold the soil firmly. The leaves reduce the effects of splashing by raindrops. We should reduce soil surface disturbance such as tilling. The loosened soil increases the risk of being washed away by the runoff. We can also break the slow length by building contour drains. So I want you to watch this image or this picture, a splash of rainwater on the ground. What happens? You see, it disturbs the soil. And the erosion removes the soft parts of the slope. Okay, so what is left is the hard part. Now, what about landslides? What is a landslide? A landslide is the movement of rock and soil down a slope. Landslides are often triggered when a slope receives too much water, especially during a monsoon session or season. It should be season. Wrong spelling. Okay? So this weakens the bonding of the soil and adds extra weights to the slope. Then the unstable soil may give way and collapse. Other contributing factors include erosion, earthquakes, volcanic eruptions, and human activities. Now, look at this landslides that can cause property damage. Look, injury and even death. Infrastructure such as roads, railways, and buildings may be damaged. The affected area needs repair work to rebuild it. You see that? Rain increases the risk of landslides. Watch this video about landslides.
Portland, Oregon, February 1996. A mountain begins to move, and for a contractor and his son, there's only one option: get out of the way fast.
Hey, dangerous. Look at that. Hey.
Oh my God! They had just gone head-to-head with one of nature's most powerful and destructive forces, a landslide. The surface of our planet is constantly reshaping itself, and landslides are a major reason. They strike wherever the soil is loosened by rain or tugged by gravity. It can be a rockfall or a raging river of mud. But wherever the ground fails, it can result in massive destruction. On average, landslides kill more than 8,000 people every year around the world. They can crash down without warning and travel for several miles. In the U.S., landslides occur in all 50 states, but some places are more dangerous than others. Landslides usually follow other natural disasters like volcanic eruptions, earthquakes, wildfires, storms, and floods. Steep slopes are obvious places for landslides, as are areas that have been hit by landslides before. But they also frequently occur where people have radically altered the landscape. Hills stripped of vegetation, slopes modified for roads and buildings. And as our cities and towns expand further, landslides become more frequent and more destructive. In 1998, disaster struck the Southern California suburb of Laguna Niguel. Few realized that the man-made hill beneath them could fail. The ground, eroded by heavy rains, began to give way, and the houses came crashing down. 7 were seriously damaged, and 5 of them tumbled down the cliff face. Though the ground cracked and the earth plummeted, no one was injured. The residents of Laguna Niguel were lucky. They still had their town. The following year in Venezuela, torrential rains triggered widespread landslides across a 25-mile-wide strip of coastline in the state of Vargas. Communities were buried under waves of mud and debris. It's estimated that 30,000 people were killed, around 10% of the area's population. Accurate death tolls were difficult to establish because so many people vanished under the mud or were swept out to sea. Though the catastrophe was on a massive scale, it is by no means unique. Such disasters have happened before and will happen again. As long as the earth continues to move, people will live with the threat of landslides.
All right. You see the effects of landslides? Dangerous. Stay away from landslide. What about sinkhole? What is a sinkhole? Well, a sinkhole is a hole in the ground formed when the soil below it collapses. You know, it happened in Bangkok, right? Several months ago. Dangerous. This happens when the rock beneath it is dissolved by water. So many sinkholes were sitting in limestone and rock salt. These rocks are soluble. Groundwater slowly erodes the rock away until it becomes too weak to support the surface of the earth. It collapses and opens up a hole. All right. What about here? I'll give you an example of a sinkhole on this picture. So sinkholes can be caused by humans too. How? Activities like extraction of groundwater, mining, construction, broken water or drain pipes, improperly compacted soil after excavation work, or even heavy rain can result in sinkholes. Watch this video about sinkholes.
How good a knight are you, Sir Duncan the Tall?
Advertisement again.
Some of the most complex civil engineering problems stem from the interaction of water and the ground. It sounds mundane, but there's a good chance you've seen one of these on the news. How's it possible for the ground to simply open up and indiscriminately swallow anything or anyone that happens to be around? I'm Grady, and this is Practical Engineering. On today's episode, we're talking about sinkholes. This video is sponsored in part by Blue Apron. More on that later. We all know about erosion. This is the process that takes soil and rock from the Earth's crust and moves it somewhere else. And there's a lot of ways this can happen: wind, landslides, abrasion, and scour. But here's the thing. None of it compares to just the movement of water. Water is the great eroder. If you ever find yourself wondering, how did this particular feature of the Earth come to be here? Or why is the ground shaped like so? Or just, why are things the way that they are? More often than not, the answer is pretty much just water. The ability of water to move soil or rock depends on several factors. The faster and more turbulent the flow, the more erosive it is. Larger particles like gravel are more resistant to erosion than small particles like silt or clay. Finally, rather than physical erosion, some materials are soluble in water, just like sugar or salt, and can be eroded just by dissolving into the groundwater over time. Most of us think about erosion on the surface of the Earth, but erosion can occur in the subsurface as well. In fact, scientists and engineers have a very creative name for just such a process: internal erosion. If just the right factors come together in the subsurface, some very interesting things can happen, including sinkholes. But let's look at a non-erosive example of groundwater movement first. This is from a video I made before the channel was even called Practical Engineering. Water's flowing from the left side of the demo, under an obstruction, and over to the right. Notice two important things. First, the movement of the water is slow. There's not a lot of open space between all that sand, so it takes time for water to flow through it. Second, the sand is confined. Even if it wanted to move, there would be nowhere for it to go. If those two conditions go away, that's when sinkholes happen. Most natural sinkholes occur in areas with large deposits of carbonate rocks like limestone. Over long periods of time, groundwater flowing through the subsurface can dissolve this rock, creating voids and open tunnels. In fact, this is how most caves are formed. These tunnels and voids create a significant change in the character of groundwater flow. First, they allow water to flow quickly, just like it would through a pipe, making it more erosive. Secondly, they create a space for soil to wash away into. With those two conditions, any soil overlying a dissolution feature runs the risk of eroding away from the inside, eventually leading to a sinkhole. But not every sinkhole is formed through natural processes. In fact, many of the most famous sinkholes in recent times have been human created. Just like a cave dissolved into the bedrock can act like a pipe and allow groundwater to carry away soil, an actual pipe can do the same thing. And actual pipes aren't limited to areas with specific geology. If you could take a look into the subsurface of any urban area, you'd see miles and miles of water, sewer, and stormwater drainage pipes. Unfortunately, we can't see into the ground, so I built this demonstration so we can see for ourselves how this works. All it takes is a little bit of settlement or shifting to create an opening in one of these pipes and allow internal erosion to start. I added a gap in my pipe to simulate this effect. Water moving through this pipe is able to dislodge the adjacent soil and carry it away. Notice there's no signal on the surface that anything is awry. As more soil is washed away, the subsurface void grows. Depending on all those soil properties we talked about earlier, this process can take days to years before anyone notices. Many of our subsurface utilities are placed directly below roadways, and the paving often acts as a final bridge above the sinkhole, hiding the void below. It's only a matter of time before everything above is swallowed up. Sinkholes aren't the only problem caused by internal erosion. A specific type of internal erosion called piping is the most common cause of failure for earthen levees and dams, including Teton Dam in Idaho, which killed 11 people and caused billions of dollars of damage when it failed in 1976. Maybe I'll build a piping demo someday for a separate video. Internal erosion can be a natural process, but sometimes sinkholes form due to bad decisions, bad construction, or just bad luck, with human-made infrastructure as well. It's just one of the many complex failure modes that civil engineers have to consider when designing any structure that might interact with water, the great eroder. Thank you for watching, and let me know what you think. Big thanks to Blue Apron for sponsoring this video. We're in the process of moving and just started to get unpacked in the new house. The last thing on my mind is going out to buy groceries. Blue Apron delivers all the farm fresh ingredients you need right to your doorstep in exactly the right proportions to create delicious recipes at home. It's essentially just the fun parts of cooking with none of the chore, which is exactly what we needed this week. If that sounds like something you'd be interested in, you can find out for free. The first 100 people that click on the link in the description will get 3
Enough of
Blue
that.
Apron meals
Okay,
with
that's
no
a
commitment.
promotion. But now, what about land subsidence? What is a land subsidence? A land subsidence is the gradual sinking of the ground due to mainly the removal of groundwater, oil, and natural minerals from the ground. However, the massive extraction of groundwater is the main reason for most land subsidence in the world. The rate of groundwater extraction exceeds the rate at which it is replenished via the natural process. This reduces the level of water table and subsequently the ability to hold the weight of the soil above. The soil above will slowly subside. Look at this picture. The land subsidence can lead to many problems. They include changes in elevation, damage to structures such as storm, drain, sanitary sewers, roads, railroads, canals, and bridges, structural damage to public and private buildings, and damage to wells. Land subsidence also increases the risk of flooding. So look at this house, which still due to land subsidence. All right, watch this video. Why parts California land is collapsing at rapid rate.
This morning, California is facing a different kind of emergency. The state's water crisis is impacting one of the world's most important farming regions, the San Joaquin Valley. The ground is literally sinking by up to 1 foot a year. Ben Tracy shows us how the land is becoming as unstable as the water supply.
Every 6 weeks, Michelle Sneed visits this white shed. She checks the pulley system and records a measurement. The numbers show that the ground beneath her feet is sinking.
We're measuring the highest rates we've ever measured here, among the highest rates ever measured in the entire world.
Sneed is a government hydrologist and says parts of California's Central Valley are dropping by 1 foot each year. Some areas are 10 feet lower than they used to be.
We would have had many, many feet of dirt above our heads right now.
That's right. That's right. We'd be standing 10 feet higher than we're standing right now.
This is why the ground is collapsing. California's farmers are pumping groundwater as fast as they can in order to keep their crops alive during a drought that has left them high and very dry. But when this much water is pumped out of the aquifer below ground, the clay between the pockets of water collapses and the ground starts to deflate like a leaky air mattress. The sinking is buckling the walls of irrigation canals, damaging pipes, creating giant sinkholes, and cracking homes. This bridge has dropped so much, the water will soon flow over it instead of under it. Fixing the damage could cost more than 100 million tax dollars.
You just have to keep going deeper and deeper.
Steve Arthur is a well driller. Some wells are now 2,500 feet deep. That's 2 Empire State Buildings underground. Water that deep is thousands of years old. But it's desperately needed because more than half of the country's fruits, vegetables, and nuts are grown here.
You tell this farmer he can't drill any more wells, he can't farm as many acres. You're going to go into the store and buy a gallon of milk for $10, a loaf of bread for $5. Then the public's going to say, hey, what happened?
So we see this progression from green to yellow to red as the state is literally drying out.
NASA's senior water scientist Jay Familietti uses satellite data to show the depletion of California's water resources. The state has lost 16 trillion gallons in the past 4 years. That's enough to fill Lake Mead, the largest reservoir in the country, twice.
So what happens when the water is simply gone?
That's a question that all of us, first of all, have a difficult time really fathoming. If we still want to have agriculture, we have to come up with the water from some other place.
But for now, the drilling continues, even with the ground all around it caving in. For CBS This Morning, Ben Tracy, California's Central Valley.
16 trillion gallons.
I know. You know, Steve Arthur, the guy from the drilling company, makes a good point. $10 for milk and $5 for bread, that will get your attention.
And the irony of all this is there's so much water.
Yes.
You know, the world is mostly water.
That's right. That's right.
You
Must
know,
figure that out.
because of that parts California land, why it's collapsing.
This morning.
Okay, so you don't have a workbook. Don't worry about that. I don't need to go over this conclusion because you know it already. The important thing is you go to page 168 of the book and check how much you understand this subtopic and or by doing test yourself 9.2. All right? Come to me. For the points, I'll check your answers. All right? That's it for today. Okay.